Hi, everybody. This is actually the second lecture of the semester. As I mentioned in lecture number one, we started with more hands-on things of frequency distributions. Now we're going to move back to chapter one, which is an introduction to statistics in this course. This is a much longer lecture and there's a lot more terms, so I wanted to do this second so that you kind of got your foot in a good hold on the frequency distributions. It's kind of more straightforward before we jump into this stuff. So I usually do this class in person, but since we're online, I hope that you can sort of do it interactively. So I'm going to ask you some questions. So what if you saw this headline, this article? So pause and see what you think about it. Come up with some thoughts about your reactions to this. Okay, you should have written down some stuff, so you should have thought about it a little bit. And I think most of us would be a little bit skeptical about this. It's a little bit unclear what this exactly means. And then the source of this study is uncertain. And since we're in a class that's statistics, we might want to say, well, where's the data? Because there's no real data presented here. So even if red wine and dark chocolate kills cancer, what is the extent of that killing? So we don't really know. And then in terms of methodology, we don't know if this was experimental or whether this was correlational. We don't know anything about how this was done. And so we need to be careful in everyday life because we're often bombarded by headlines like this, and we need to be very careful about believing these types of things. Because this sounds great, right? You drink red wine and you eat dark chocolate and you are fine. You don't have to worry about cancer. It's kind of implying it a little bit. That's probably overly simplistic, correct? How about this one? So go ahead and pause and see what you think about this. So the headline's a little bit provocative. So what do you mean by smarter? If we actually, there's a little bit down here. It says females do outshine boys at school and university. And so it's a little bit more specific. So obviously it has to do with GPA. But again, we have some of the same questions. In this case, we can't say whether it's an experiment or not because you can't manipulate whether somebody's a man or a woman. So it's obviously correlational. But how big is the difference? We don't know. It just says that they're smarter than men, but we don't know how big the difference is. And so we need to be very careful in real life because there's often these sensational headlines, but we don't know exactly what it means or how big the difference is. And so part of this course, I hope, is that you're learning to ask these questions and to become more savvy about asking questions such as how big is this difference between these two groups? Or is it such a small difference that in reality it doesn't really matter? So we're going to talk a lot about these types of issues, about evaluating these types of claims in our class. So that's really what our course is about, is thinking about these claims that people make and what is the evidence for those claims and whether that evidence actually backs up their claims or whether the claims need to be a little bit more modest. So in terms of stats, those two things we might want to ask, is the effect real? So does dark chocolate and red wine really kill cancer? Do women have a higher GPA? I think GPA we have to stick to, not smarter. Do women have higher GPA than men? Is it something that's a believable, reliable effect? And so that's one thing that we're going to be looking at in terms of this class. So we've already talked about descriptive statistics. We've started that already with frequency distributions. We're going to continue that for the next couple lectures. But towards the end of this unit, and definitely starting with the next unit, we start answering these types of questions. Is the effect real? Is it believable? So in terms of stats, these types of questions are what we call inferential statistics. And so if your sample shows that dark chocolate kills cancer, or that women are smarter than men in defining it as GPA, how much can we take those data from the sample and say it's believable about everybody, about human beings in general? And so that reliability question is one aspect of inferential statistics. Inferential is taking a sample's data and making a conclusion, making an inference about a population. So your small group in your study, can you make a conclusion about people in general? So this is one thing we're going to look at in this class. And the other thing we're going to look at is this question that we just talked about. How large is the effect? So while you say dark chocolate kills cancer, well, what is it? Is it improving somebody's ability to fight off cancer 5% or 20% or 50% or 100%? What's the size of the effect? Or in terms of the men and women, in terms of GPA, how much larger is women's GPA compared to men? What's that difference? How big is that difference? Is it a small difference or is it a big difference? And so in statistics, we call this an effect size. So how big is that difference? And so in statistics, what we're going to be talking about later in the semester is in inferential statistics, when we're taking a sample and we're testing hypotheses to make conclusions about a population, we do both of these things. First, we say, is it something that's reliable? If we repeated this study many times with the same sample size, how often would we find this effect, this difference? And then we're going to do the second thing also, which is, okay, if it's reliable, is it something that makes a big difference in everyday life? So how big of an effect does dark chocolate have on cancer? How big is the difference between women's and men's GPA? How big is it? And this is an important question to answer also, because in terms of the first question about whether it's believable or reliable, if we have a pretty decent sample size, and it doesn't have to be that big, a sample size of 50 to 100 people in your sample, you could have a relatively small difference, small effect, and it would be reliable. And so we want to ask both of these questions. Not only is it reliable, but how big is the difference? Because we know if we have larger samples, something that is a small effect, so a small effect of dark chocolate or a small difference between men and women's GPA, that will still come out as reliable if we have a big enough sample. So we have to always ask, does it make a difference in the real world? And I think these are questions that kind of come in our mind right here. You know, it's like, well, do I want to believe this? Is this something reliable, or did they do the study in such a weird way that it's not something that you would see repeated in other studies? Both of these. Or we also, and hopefully, we also ask questions, well, how big is this impact? So you're saying that dark chocolate kills cancer. Really, how much does it do that? Is it just a very small difference, or is it a big difference? Same for this. So women have higher GPAs, but how much higher? Is it 0.01 difference, or is it 0.1 difference, or is it a 1 grade difference? If it's a 1 grade difference, then I'd say, wow, that is a meaningful difference. 0.1 difference, maybe not. The 0.01 certainly is like, well, that's really small. That doesn't really have a big impact in the real world. So probably these questions came up in our mind when we saw these two things. Can we believe this thing, and really how big is the impact of these things? So actually, I like to say that statistics were actually doing common sense things. The problem is statistics are talked about and taught and written about in textbooks in a way that makes it seem so complicated and difficult. And so I hope one of the things that you'll learn in this class is how to decode that language. Things that look complicated are actually pretty simple. So how do we decode those things? So I hope that you'll learn those things through this class. So why should you take this class? You're probably taking it because you need one, a transfer level math class, or two, you might be taking it because you're a psych major or a sociology major and you need it for your methods class. But beyond that, I hope that some of the things that you would get out of this is, just as we talked about just now, better consumer research. So there's a lot of media attention about studies, and there's a lot of pop psychology out there too. So there's a ton of pop psychology. For example, if you go to a bookstore or just go onto Amazon, I think even, if you go to a psychology section, there'll be a lot of what we call pop psychology, popular psychology. And then a lot of that is just nonsense. It's not based on research. It misinterprets research or misrepresents research. Because in the end, those authors and those people in the media, they want to sell you stuff. And so if somebody said, if this article said something like, dark chocolate will reduce your risk of cancer by 0.01%, would you read the article? Probably not. Or if this said something like, women have a 0.01 higher GPA than men do, you wouldn't read the article. You wouldn't buy the book. So there's a lot of sensationalism there. So I think one of the things that you'll take from this course, hopefully, is to become more critical about all the stuff that's out there and become a better consumer. Because a lot of times people read these things and they act upon these things, and it could actually be harmful, or it just has no effect. And so I hope that you become a better consumer of research, and this applies to all things in life. And so if you go to the bookstore and you look at the psychology section, quote unquote, probably 80% of the books are about two things, are about love relationships, romantic relationships, and about raising kids. Well, big surprise, those are two things that people are incredibly anxious about and are important things in your life. So people prey on that, and they know they can sell you books and workshops about these types of things. And so I hope that you can be on guard against people who are wanting to take your money over nonsense and be more evaluative of things. So psychology has a lot to say about those topics, but that stuff rarely goes into those books that go out into the public. So I want you to be better consumers. Power. So I was going to mention that a little bit earlier, but I decided to bite my tongue. Is I sort of was just talking about that we want to decode the language of statistics, because really I think statistics is just sort of common sense, and it's just a way of understanding the world. It's really quite simple. However, there's so many complicated terms and ways that people talk about these things, and I think in part that's intentional. And I think part of the intention is power. So if people feel bad about math, feel like they don't know math, feel like they can't do statistics, don't understand numbers, or I don't know what that means, I'm not good at math, guess what? It allows for people in power to manipulate you a lot more. So I hope that by understanding numbers, understanding the reasoning behind sort of quantitative presentation of things, will give you more power in life. So you need to better understand those things so that you just don't say, well, whatever, and let people make decisions about your life and your community that are not well based in the numbers. Also, it can lead to possible careers. And so there's different things. So you could actually work with numbers and become an analyst of numbers. There's different occupations for that. So you could, go into insurance. I would be bored by that, but if you like numbers, it's called actuary science. It's looking at probabilities, and so that's how they charge you different insurance rates and get away with it because I think they're really discriminatory in many ways, but they say the numbers back it up, so they get away with it. So why do men pay higher driver's insurance than women? Well, they got somebody crunching numbers and says the probability of a man getting in an accident is this much higher than women, and so they quantify it, and then they charge you higher rates. It's not my game. I won't want to necessarily do that, but that's just an example. But there's really some nice jobs in the California community colleges, and they're still sort of there. Um, they're called research analyst jobs, institutional research. So every community college, for example, in California, has an institutional research office, and many community colleges and universities have institutional research offices where they need people to look at numbers and analyze numbers with statistics. And so, actually, I did this last year, but I think the range of salaries are pretty similar. And so, for example, uh, looking at the community colleges in California and looking for research jobs and institutional research, people who basically pull, they call it pull. So there's like a lot of data about you, right? There's all your application data, there's your grades, there's all of this stuff that the university colleges have in terms of you and whether you're successful, how many times you've taken a course, all this type of stuff. They have all these data. So these people analyze those data to see how students are doing. And the aim of it is hopefully to make recommendations to improve your education in community college. So just some sample jobs that I got off of it's called CCC Registry. So it's the California Community Colleges Registry of Jobs. And so what's called sort of an entry level. So if you have a bachelor's degree, typically in social science, and 3 years of experience in research or statistics, that's an entry level job. Or you could have a master's with no uh, years of experience. So a master's would be counting for years of experience here. The entry level would be 67,000 to 85,000, and you can move up pretty quickly. So every year you move up and get at least 3,000 more at least. So this would be the span for a entry level job with a bachelor's and some experience or a master's. The next step, which would be like a director um, or a manager even. So, but a director, it could go from 95,000 to 115,000. Typically, these people would have had some experience in institutional research for maybe 3 to 5 years. So once you're at the entry level, then if you add 3 to 5 years, you could go to this next step. Some people can go very fast. So I was working in institutional research at Norco College, and one of my colleagues there had a master's degree, but it was a master's degree, I think, in um, like ocean sciences or something like that. It wasn't social science; it was just a master's. But he knew statistics, so he didn't really know much about the content of education or psychology, but he knew statistics. So he got an entry level job, and he was in that job for less than a year and a half. And he was able to get a director job at RCC, Riverside City College. And that job had this range that you're seeing right there at the next step, 95,000 to 115,000. And so, that's with basically a master's and less than 2 years experience making that amount of money. A bachelor's person, you could probably take that next step if you've worked for maybe 5 to 7 years. And then at a higher level, a dean, when I was looking at this, there was a dean position offered in Kern County, and the range that for the dean position was $117,000 to $154,000. In Kern County, that can go quite a long ways. And this type of a person probably would have 3 to 5 more years of experience beyond that middle step there. So I'm not really trying to impress you with money per se, but you know, it's nice to have money. It opens up a lot of opportunities. And so if you know numbers, if you know how to do statistics, there are a lot of career opportunities, not just in community colleges, but in business, in any sector. Uh, People are analyzing data all the time. Real estate companies analyze data all the time. So there's almost no sector of work that doesn't have somebody who's analyzing data. And so it can open up a lot of opportunities. And these are very stable opportunities. So a lot of people who go into this institutional research jobs, they're there forever. They're working in a community college for 30, 40 years. And they're getting full benefits of medical and dental, and they're getting life insurance paid, and they're getting retirement money. And so it's actually a really solid pathway. But again, you don't necessarily need to go into a research job to have your statistical skills be valued. So uh, for me, I consider myself a developmental psychologist, personality psychologist. And so I've never said I'm just a statistician. I don't consider myself that, even though I know how to do statistics. So my love is psychology, and I've always done psychology type of stuff. But I've had statistics and the ability to use numbers and analyze numbers in my pocket as a skill, and that has helped me get a lot of jobs. And so I'm not saying that you have to love statistics and only do statistics, but you can do your stuff, you can do the stuff that you love. And if you have the statistical knowledge in your pocket, you're going to have an advantage against every other applicant, because every other applicant's going to love that thing or love that area, but they probably won't know statistics. If you know statistics, you have a step up on everybody else. So I would encourage you to think about having statistics as something that you might keep in your pocket as a skill that's very marketable in the real world. People will give you jobs, pay you a lot of money because of this. And this is sort of the double-edged sword. So I don't like that statistics are taught in a way and conveyed in a way to confuse people and to make it seem complicated. I really wish that it was much more straightforward, because it really is straightforward stuff. But the other end of that is that if you know statistics, if you know how to use numbers, that gives you a huge advantage in the world, because so many people say, oh, I don't know numbers, I'm not good at math. It gives you an automatic step or two ahead in terms of careers and jobs, if you can do those things, because people are often afraid of math. So if you can do it, it's a really great skill. And again, people will give you jobs and pay you for it. So my own story, I've sort of been sort of alluding to that I consider myself psychology. I'm interested in psychology, and that's my love. But I've always had those statistical skills and research skills in my pocket. And I would say that probably 80% of my jobs that I've had, one of the primary reasons that I got those jobs was because I could do statistics and do research. And so I've always had full-time work, even now. The COVID situation hit me pretty hard because I was on the bottom there. I had gotten a full-time job at Chafee for a year, and not just Chafee, but it sort of set me in line to possibly get a tenure track job, which is a permanent job teaching at other places. So in this area here, in the sort of 3 county area of sort of Riverside and San Bernardino and Orange County, there was quite a few jobs that were advertised that had statistics in it. But COVID came along and cut me off. And so, but I was able to get another full time job elsewhere. And so in my life, statistics and knowing statistics has helped me get jobs and full-time employment. I'd say probably 80% of my jobs. Also, I grew up as a poor kid, and government housing and food stamps all the time, and sometimes on welfare. So, I was a poor kid growing up, and I got through college. Um, but I got through it, working a lot and things like that. And so by the time I graduated from college and went to grad school, I was also poor in grad school and, took up a lot of debt and things like that. And so by the time I was graduating from my PhD program, I really didn't have a lot of money. And I did have a job for a couple of years at college and teaching, but it wasn't paying a lot of money. And I had always wanted to go to Asia, but I couldn't just travel. Rich people can just travel and spend money and do whatever they want. But when you're poor, you just can't go to Asia. You don't have money to do it. And so I thought, well, always wanted to go to Asia. So the way I could do it as a poor person is to get a job there. And so I looked for jobs at places that paid decently, and I was able to get a job in Singapore. And so that job in Singapore, a big part of why I got that was because I knew research methods and I knew statistics. And so I got a job there. And when I was there at that university, I worked there for 2 years. And then one of my former colleagues became a boss at another school, and he recruited me because he needed somebody who could do statistics and could do research. And so he actually recruited me, and so I got another job, and I worked there for about 3 years. And then I moved to Hong Kong, and I was able to get a job in Hong Kong because of statistics and research. So I was doing basically institutional research in Hong Kong, and I got that job almost 100% solely because I could do statistics. And so that sort of very great thing in my life of being able to live in Asia for 12 years was 98% due to my ability of being able to do statistics. And that was something that I would not have been able to do to explore the world, to explore Asia, because I was a poor kid. I couldn't have done that on my own. So statistics actually took me over there and gave me many great experiences. So I'm making sort of a personal story here is that, if you can do statistics and have it in your pocket, it can be a thing that opens up doors and opens up opportunities, not just in terms of career, but if you can do numbers, you can do numbers here, you can do numbers in Asia, you can do numbers in Europe, you can do numbers in South America. Those numbers, those statistics stuff is the same. And so it's a way of opening up the world in some ways. And so I do think that statistics is something that is important, and if you can do it, I think it opens up many avenues. Okay, so let's get back to the substance of the course. So this is basically the overview of the lecture. We're going to cover many things. So we're going to cover the basics of research and the place of statistics in research. We'll just review really quickly the process of research, which many of you probably already know. We're going to go talk about the different types of variables used in research and this issue of cause and effect inferences. We're going to talk about something very important in terms of levels of measurement. That's going to be actually the last thing. I'm not sure why it's there. And then discrete versus continuous variables, population versus sample, and descriptive versus inferential statistics. So all of these things are what we're going to cover. So as I mentioned earlier, is that this lecture, chapter 1, there's a lot of terms, so I wanted to do it second rather than first. Before I go on, when I was doing the video for the syllabus and course overview, I mentioned the math skills assessment in Appendix A. And so if you feel iffy about your math skills, you should probably review some of these things. And if you feel really iffy about your math skills, you might want to take a test, an assessment of that. And so you might want to just sort of see if you're up for it. I think there could be a small amount of people that need to probably take a course that reviews the basic math before they take this. If you feel anxious about math, don't worry. You'll get through it. I'll help you through it. If you just don't understand the basics of math, then that might be more difficult. But don't drop just out of the blue. If you have some questions, you can always ask me. But do look at Appendix A because that will help you review the things that you need for this course. So this is a relatively long lecture. There's a lot of terms, there's a lot of information, but we do need a starting point as before we go on further into the course. So some of these things you might not understand fully. That's okay. This is just the beginning of the course. So if you don't understand something, don't worry. We'll cover it more later in the course, or you can certainly ask me questions. So don't panic. There's just a lot of information. I don't expect you to understand everything right away because a lot of the stuff we're going to cover throughout the course. So the process of research, I sort of mentioned this earlier, is that probably a lot of you already know this. So the process of research is you start with some sort of theory. Based on that theory, you generate some research questions, and then you specify specific hypothesis. Then you define your variables. So once you have your hypotheses, you're thinking about what your variables are. And very important, you have to think about how you're going to measure those variables. So I had mentioned earlier in lecture 1 about narcissism. So if I'm going to study narcissism, am I going to measure it with a questionnaire? Or am I going to measure it by asking friends of the person about how they act? Or am I going to set up situations where I have experts in psychology observe the person and make some sort of ratings about that person's behavior that will lead to scores on narcissism? So there's different ways I could measure narcissism. And so one of the questions that we do in the process of research is how are we going to measure the stuff that we're curious about, the variables? We also want to think about designing the study. So are we going to have an experiment where we manipulate some sort of variable? Or are we just going to watch people in the real world and we're not going to manipulate anything? We'll talk more about this later in the semester about different designs of the study, but this is the nitty-gritty. So the nitty-gritty is, what are your variables? How are you going to measure it? How are you going to design your study to evaluate those research questions that you have? So once you figure out how you're going to do your study, how you're going to measure your variables, then obviously you do your study, you actually collect data. Once you've collected your data, you have to analyze your data. And then once you have your statistics, your analysis, you have to interpret those data. So what do those data mean? What's the meaning of those numbers? And then those interpretations of the data then go back into the theory. So it might say it supports the theory, or it might say that the theory needs to be revised, or maybe the theory needs to be thrown out. So you're probably very familiar with this process. And this process, we call it like an hourglass. So you start off general. A theory is relatively general. You get more specific. Your hypotheses become a little bit more specific. Then you think about your actual study. That's really, really specific. How are you going to run your study? How are you going to measure your variables? And then very specific is your data. And then analyzing your data is very specific. Statistics are very specific. But then you have to broaden out. So yes, you have these numbers, but what does it mean? Who cares? Numbers don't mean anything unless you can tie it to a larger theory and make sense of it to say, this says something about what people are like. And then obviously the last part there is you take your study and you try to feed it into a larger, broader perspective of theory. So it's an hourglass. You go general to more specific to very specific to a little bit more general to very general at the end. And this course obviously is looking at these two steps of analyzing the data and interpreting the data. And if you're a psychology major or a sociology major and you're going to be taking research methods after this course, research methods will cover all of these steps. So let's look at some terms. We can't avoid it. We have to get into it. The first sentence is just, I think, from your book. Statistics means statistical procedures. This type of thing drives me batty. Your book is pretty good, but your book also falls prey to some of the stuff in statistics. Is just, why can't you just say it's statistics rather than having to define it with statistical procedures? It just sounds a little silly. So we have to be mindful of that. Again, part of this is decoding things and understanding the language. So basically, there's two types or two uses of statistics. One type of statistics, which we're already started covering, is descriptive statistics. Descriptive statistics describes the sample. So when we did our frequency distributions, we looked at the frequency distributions to describe the sample on a certain type of variable. So for the sample, in general, how much sleep did they get during the first week of class? Well, the first week of class, they got a decent amount of sleep. Maybe not enough people got 8 hours, but at least 40% of people got 8 hours or more. And most people, I think, got between 6 and 7. So it wasn't too bad. But during the midterm week, people got a lot less sleep. And so we're describing the sample on variables. So when we describe the sample, what we're really doing is we're organizing and summarizing information. So the stuff that we were doing with the frequency distributions and describing those things was a way of organizing and summarizing information about the sample. So that's one type of statistic. And we're going to basically do this for this first week and a half, roughly, of the course. Then once we've done that, that's kind of basic stuff. So when we're describing the sample, we're not doing any test of hypotheses. We're just describing a sample. So we want to tell people whether, if it's narcissism, is this sample, average on narcissism, or is this sample pretty high on narcissism, or is this sample pretty low? People want to know that. They want to know what your sample looks like. But the reason we do research is we want to make conclusions about our research question based on the sample's findings. So that's called inferential statistics. So if we're taking the sample's data and testing hypotheses about our research questions, and therefore from that sample's data, we're making some conclusions, some inferences about people in general, the population, that's inferential statistics. So inferential statistics will be what we're mainly going to be doing in this course, because that's the most important part of statistics is, can we make some sort of conclusion about people in general from your sample in your study? So we've already talked about this. So population are the people that you're inferring about. So I was talking about in psychology, we often sort of implicitly, at least, have human beings as our population. So if I do a study on narcissism, I hope that I can talk about narcissists in general, whether they're here or in Asia or in South America, that narcissists are like this. Narcissists that are human beings are like this. But sometimes people want to make inferences to a smaller population. That's fine. So if you were going to do a study and you were curious about what helps Chaffey College students succeed in their courses, well, your population would be Chaffey College students. And so you do your study and you get a sample from people at Chaffey College, and your inference would be Chaffey College students are like this, etc. You would not say, well, students at Harvard look like this, or students in Asia at universities look like this. You would just limit your inference to Chaffey College students. So it can vary. in size. Again, in psychology, we tend to be pretty grandiose and we want to talk about people in general, but it can be other things. So you can look at Chaffey College students. You could also look at football players at Chaffey College if you wanted to. You could take a sample of football players at Chaffey College and make inferences about football players at Chaffey College. Or maybe it's first year students. So you're curious about how first year students make their transition from other schools or high schools to Chaffey College. So you study first year students, and that's your inference would be to that population. So a population is basically who you want to make conclusions about from your study. A sample is who you actually get data from. So probably every one of these things, maybe the football players you could do possibly, but it would be maybe a little bit unethical because maybe the coach would have to force people into your study. That's not really ethical. But even something as small as first year students at Chaffey College, I'll guarantee you I could give you $100 million. You probably, maybe 100 million is a little bit too much, but 10 million even, let's just say. I probably could give you $10 million and probably you cannot get every single first year Chaffey College student. Somebody would refuse to be in your study, or somebody would run from you, or you can't get a hold of them. You go to their class, they're not there. You call them on the phone, they don't answer. You give them an email, they won't answer your email. So probably, realistically, we really can't get data from everybody in our population. So, and we don't need to. The nice thing about statistics is that we don't need to. Research doesn't need to have everybody in the population be sampled. We can collect data from a smaller group of people and make inferences to a much bigger group of people using statistics. And we'll talk about that later in this unit. I think maybe the start of next unit. So the sample is the people who we actually get for our study, and we actually measure them. And what's really important is that we want our sample to represent our population. This is what in psychology, we're sort of guilty of this. We often will have a sample that's not representative, obviously, of the world, but then we make conclusions about people in general. We're kind of guilty of doing that. But what you want to do is you want to have a sample that's representative of the population in your research study. And why is that? Because the more representative your sample is of your population, the more confidence we have making inferences from that sample to the population. And so, for example, let's take Chaffey College students. So Chaffey College students, they vary on many things. So race, ethnicity, country of origin, or the country. We have a lot of international students. We have male, female, trans, non-binary people, etc. And then we also have different ages of students. And so we have all of this variety of people at Chaffey College. And so if we were going to do a study and our population that we want to make inferences to was Chaffey College students, we want a sample to be representative of all those differences that we see in students at Chaffey College. Because let's say that let's just say we sample people and we get 95% of our sample was people from age 18 to 24. Well, that's probably not very representative of Chaffey College students. We have a lot of students who are older than 24. And so if we have a biased sample that doesn't represent all of the variety of Chaffey College students, our sample is really difficult to say that our sample, we can make conclusions about the population because we don't have all of the variety, all of the representativeness of the population in our sample. So what's the best strategy of getting the representative sample? It's random sampling. What's random sampling? It's quite simple. Once you have your population identified, you randomly select people to be in your study. And so if Chaffey College students is your population, every single Chaffey College student should have an equal and random chance to be selected to be in your study. That's what random sampling is. So there it is right there. So everybody in the population, every Chaffey College student has an equal chance of being in your study. Again, this is the simplest method to reduce bias and to get a representative sample. And so the last point here is, let's just think about Chaffey College students. Let's say I was doing a study. Let's say I did a study with 10 people. Would that be representative of Chaffey College students? Well, probably not, because can 10 people represent all of the variety and diversity of Chaffey College students? Maybe not. Probably not. It'd be very difficult to do. How about 50? It's getting better, maybe. How about 100? Maybe so. How about 200? Getting much more likely, right? So it should make some sense that the more people in your sample, the more likelihood you can represent the variety of the population. And so as your sample sizes increases, the representativeness increases also of the sample. And so representativeness of the sample, we often do this random sampling. A really good technique is called stratified random sample. And so if you are really concerned about this, doing a stratified random sample is great. And so what a stratified random sample is that you identify those things that makes a difference. So, race, ethnicity makes a difference. And so you find out the percentages of different races and ethnicities at Chaffey College. And what you do is you make sure that your sample has the same percentages. And then within each of those groups, so you have categories of people in those percentages, you want to randomly select people with that category, in that category, to be in your study. And that's the same for anything. So gender is a big concern. You want to make sure that you have a representative representation of gender identities. You find out what the percentage is for Chaffey College, and then you randomly select people in those different gender identities to be in your study so that it represents the diversity of Chaffey College students. So you could do that with ages also. You could put people in age brackets, find out what the percentage is of those age brackets at Chaffey College, and then you want to make sure that your sample has those percentages in those age brackets also. And what you do is you randomly select people within those groups, within those age groups. The dirty truth is that in psychology, certainly, and I think in a lot of other disciplines too, but definitely in psychology, we're guilty of what's called convenience sampling. So usually in psychology, we do not get a random sample. Usually what happens is there's a lot of research that's done on college students. So we don't have this system here at Chaffey College, but if you went to a four-year school, I would almost guarantee you that if you took an intro psych course, you would automatically be in what's called the subject pool. And so your intro psych teacher would say, well, part of this course, you need to learn research. And to learn research, you should be participants in research. Ethically, they can't force you to do it. So usually they give an alternative assignment, like a paper. You read a research article and write a paper. The problem is with that, it's not equivalent, right? Most people don't want to read something and write a paper just to get their requirement done. And so it's a lot easier for people to do the research. So they end up doing the research. So in psychology, we often use people who are convenient to recruit. And so we're a bit guilty on that. And here's sort of a simple graph showing what we were just sort of talking about. So we start at the top here. The population is the people that we want to make a conclusion about, the people that we're interested in. And so we need to select a small subset of those people because we can't measure everybody. And so the sample is from that population. And so that sample is the people that the research is done with. And so we collect data on those people, and then those data from that sample, from those small set of people, are used to make inferences about the full population. So we've talked about that before. That's just a simple graph showing that relationship. So this lecture, we have a lot of terms. So one term that we've already talked about in lecture 1, which is variables. So I just basically told you a very simple definition. So variable is something that people differ on. They vary. And so narcissism is a variable. Some people are high on it. Some people are low. Some people are in the middle. Uh, Something as simple as hours of slept in a night. So that's one of the variables we looked at in lecture 1 and lab 1 was the amount of sleep that people get. So people vary in the amount of sleep. So a variable is just simply something that people differ on. So I have things here such as narcissism. I already talked about that. It could be something a little bit more complex like romantic attachment. Romantic attachment, I'll use as an example, I think, throughout the course. It's basically how people think, feel, and organize their memories about relationships. And so people differ on that. So some people are very secure and very open to their emotions and understand other people's emotions and communicate well about emotions. And then we have people who are overwhelmed with their emotions, who are anxious, who are jealous about their partner, who, if they're not in a relationship, they feel like they need somebody, that they can't do it on their own. They feel lonely and they need somebody to fill them. And then we have people who are distant from their emotions, who cut off their emotions, who don't like strong emotions, who don't like to admit that they're vulnerable. And so people differ in terms of their attachment. There's sort of 3 categories I just talked about there. Another thing I've studied is hookup culture beliefs. So there's beliefs that hooking up is harmless, hooking up is a good way to gain status, hooking up is a good way to explore your sexuality. And so people differ on these beliefs. And so I've done studies on this, and I've measured the differences in people's beliefs about these aspects of hookup culture. So it could be many, many different things, even things like height, weight. You can measure these things. People differ. Some people are tall, some people are shorter. So this is something where people differ on. So pretty much anything that people differ on and that you can measure, it's a variable. So again, terms, data. By the way, data is a plural word. So data are. So data are just those numbers. So we already looked at data. So when we did our analyses of the frequency distributions, we looked at numbers for people, and those numbers were data. So how much sleep somebody got first week of the semester, midterm, week after midterm, and I think the spring break was also the other one. So we actually looked at those data for those people. And a data set. A data set is what we use in the analysis of the frequency distribution. So when I was in SPSS and I showed you the data, that's a data set. So I told you that each column is a variable, each row is a person. And in the sleep thing, we had 40 people. And for each of those 40 people, they had a row that had measures the number of hours that they got for those 4 different times in the semester. That's a data set. More terms, parameter versus statistic. So the distinction here is just that between samples and populations. So when we have numbers where we're talking about a sample, that is a statistic. So any number that has to do with a sample is a statistic. Any number that has to do with a population, and usually these are estimated because we usually don't measure everybody in our population, that's called a parameter. And again, we usually estimate it from the sample's data. So statistic comes from a sample, And it's 100% sure because we have all the data from the sample, so we know specifically what a statistic is. Parameter is about a population, and we usually, whoops, sorry about that, we usually estimate that from the sample's data because we usually don't measure everybody from the population. So the point here is that in statistics, we have different symbols for these different things, even though it means the same thing. So you all know what an average is, right? If I said, can you calculate an average for a group? You know how to do it, right? You take the scores for the group. Let's just use let's say exam scores. So let's say I give the first exam and I add together everybody's score on the exam from the class and I divide it by the number of people in the class. That's an average. You've been doing that forever. So there's actually an average for the sample and an average for the population. So we have different symbols, and we'll talk more about this throughout the course, so don't worry if you feel a little bit iffy about that, but I'm just sort of warning you, as in statistics, we talk separately about statistics and parameters in terms of symbols. So the average for a sample, which you can calculate because your sample's there, you have the data. So you can actually add up everybody's score, divide by the number of people in your sample, that's your average. It has this symbol right here. We call it X bar. That is the average for the sample, and that's the statistic, and we actually know that statistic exactly because we have all those numbers. The average for a population has this symbol. It's called mu. If I can highlight it with the cursor here, right here, that's called a mu. It's the same thing, it's an average. And how you calculate the average is exactly the same. It's just that you use different symbols, whether you're talking about the sample or whether you're talking about the population. Whether you're talking about a statistic from the sample or a parameter from the population. And again, the statistics we always know because we have the data from the sample. The population, the parameters, we oftentimes have to estimate those things because we don't have numbers from everybody in our population. So there's kind of 2 points there. One is that we know statistics very specifically because it's about our sample, we have those numbers. For population parameters, we estimate those things, usually based on the sample's data. And the other sort of tricky thing is that we use different symbols for the same exact stupid thing. So the average has a different symbol, whether it's a statistic from the sample or a parameter from a population. So if you want to remember this, it's relatively easy. Statistic, sample, both S's. Statistic, sample. P, parameter, population, both P. Statistic, sample, we know all the data from the sample, so we know it. It's 100% known. P, parameter, it's about a population. We usually can't measure everybody in the population, so we usually have to estimate it. Okay, more terms, and we've already talked about this. We've already talked about descriptive versus inferential. So descriptive is just about the sample. So we're just telling people, what is our sample like? So you studied narcissism, what does your sample look like on narcissism? Well, they're relatively high, or they're relatively low, or they're just kind of average on it. So we summarize and we organize the data in a way to tell that story to the people that are looking at our research. What does our sample look like on that variable? And we've already done these, so we've seen things like tables and graphs for the frequency distributions. And then our next 2 topics of lectures in this class are about averages and variability. So one way to summarize the data is, on average, what was the average score in narcissism for your sample? Also, variability is how much do people differ? Did your sample vary a lot on narcissism, or did they vary a little bit on narcissism? So these are all descriptive statistics. It's all just about describing the sample. in terms of the variable that you measured. Inferential statistic, again, is taking the sample's data and making a generalization, making an inference about the population, so making a conclusion. So you don't do research just to talk about your sample. That would be stupid. Nobody would care about it. We do research because we can take those samples' data and we can make some sort of conclusion about the population in general. And so inferential statistics, again, are about testing hypotheses. And inferential statistics are also about interpreting your data. So there's not a lot of interpretation in terms of descriptive statistics because we're just telling people what does it look like? What does our sample look like? There's not any interpretation. It's just what does it look like? Inferential statistics, that we're taking the stats and we're actually making an interpretation. What does that number mean? What does that number mean in terms of our hypotheses and testing our hypothesis? What does that number mean in terms of what people are like? In general, beyond your sample, in the population. So inferential statistics, a lot of what we talk about are things like probability. So remember we started a lecture about those two things, the dark chocolate stuff, red wine and dark chocolate, and cancer. You can tell I like chocolate. I don't drink anymore. So I love chocolate. It wasn't a compensation. I always loved chocolate. So I remember the dark chocolate stuff better than the red wine stuff in terms of the cancer. And then the women versus men in terms of their GPA. So we talked about those things. And one of the things we asked is it reliable? So inferential statistics gets to that question of, is it reliable? How likely is that difference you found in your study that dark chocolate kills cancer? How likely does that apply to every other case in the world where people are eating dark chocolate? Is it for them helping kill cancer? Or was it just something that was weird and you had a weird sample? And you can't infer things beyond your sample to the general population of chocolate eaters. So when we talk about inferential statistics, there's things like what we call margin of error, significance, and probability. So we're talking about probabilities. So what's the probability that the stuff that you saw with dark chocolate killing cancer in your sample, what's the probability that applies to everybody else in the world? So inferential statistics are about probability and reliability. Descriptive statistics are certain again. So remember descriptive statistics? Statistics tend to be very certain. So descriptive, we know what a mean is. We know what people's variability are in your sample. However, there's no guarantee that your sample's findings will apply to everybody in the world. So we want to talk about probability in inferential statistics. So when we make inferences, it's with some sort of probability statement about how likely our sample's data, what we found there, applies to everybody else. So a quick little thing here about what things go together. Pause your video and actually answer this. Okay, you should have answered this already, so I'm going to continue. So remember S's, sample statistic. And remember with sample, we're talking about statistics, but also with a sample, we're talking mainly about descriptive statistics. So descriptives has to do with sample. So sample, statistic, samples, descriptives. P, population and parameter go together. And in inferential statistics, we're taking our samples data and we're making inferences about the population. So I'd say that inferential statistics ultimately have to do with population because we're making conclusions about a population from the samples data. Don't worry about this slide. We're not going to cover it in detail now. It's better for a discussion in the class. So let's explore a little bit more about inferential statistics. So when we're taking the samples data and we're making conclusions about population. So, we have a big election coming up, and people are taking polls. Actually, I'm gonna kill somebody because somebody from, I think it's 714, somebody from Orange County, I think that is. Some computer keeps on calling my stupid phone, my landline that I'm locked in because it's cheaper to have the landline and with my cable than not having a landline. So I do have a landline because it's cheaper to have it than not have it. But they sell the stupid number, I think, and I get all these stupid calls. So a computer has been calling me, I think, 5 to 10 times a day at least about the election. And so I try to tell it to stop calling me, but it doesn't listen, of course. And so big election coming up. So there's all these polls coming up, and each of these polls will have a margin of error. So what does that mean? So probably some of you are thinking, well, that means that these polls that people take, they obviously are samples of people. You're not getting everybody who's going to vote. Because it is a sample, and samples represent more or less the population, there's always going to be some sort of margin of error. Even if you have a pretty good sample, there's still going to be something that's off. It's not going to be fully representative of the population. So the sample is not your population, and so there's always going to be something that's off in those numbers. They can tell you what their sample said in terms of who they're going to vote for, but they realize that the actual people who are actually going to vote are different. There's a subset of people that are in your sample that will vote, but there's some people who say they will vote, but they won't. And there's people that said, well, I'm not going to vote, and they actually end up voting. So we know that the sample's not going to be perfect with the population. So there's always going to be some error in your numbers. So your sample says that they're going to vote for this person or this person. You have those percentages, but you know it's going to be off a bit. And so this is a poll that was taken quite a bit ago. This is 2019. And so this is in California, I think. And so in California in 2019, this is what people said in terms of who they would vote for. And here I think it's basically considering who they would vote for, because it doesn't add up to 100, obviously. So there's multiple candidates that they're considering. But you can see here about who Californians in 2019 considered that they would vote for and not vote for. But there's a margin of error. If you go down here, it says, I have to find it. So the sample was 2,272 Californians who said they're likely to participate in the Democratic primary. And here it says the sampling error is plus or minus 3 percentage points. So plus or minus 3 percentage points, which means that Warren probably at this time, at the time of when they asked this question, 65 to 71% of Californians would have been happy with having her as their candidate. Biden would have been 43 to 49. So you take 3 percentage points off, add 3 percentage points, and there's that band. And probably that band is not 100%. It's probably 95% sure or 90%. So probably 95%. So 95% sure of people at this time in in September of 2019, at that time, 95% sure that 43% to 49% of people would have been willing to support Biden in California as a Democratic nominee. So you're probably pretty familiar with that. So it's just saying that there's some error, some differences between the sample and the population. And so this has to do with probability. So when we talk about inferential statistics, we're always talking about probability. How probable are these numbers? And what's the band of certainty? So the band of certainty is minus 3% to plus 3%. How about this? So why don't you pause the video and see what you think about this? So probably some of your reactions to this is, well, what does this mean? Predict when a person will die. Does it mean that you got the date? Well, probably not. Probably most of us will realize that if you're looking at statistics, it's probably a band of plus or minus 3 years, maybe 5 years, maybe 7 years. So there's always going to be a margin of error about these predictions. And so one of the things in these inferential statistics is to keep in mind this stuff. So when you read this, you might panic. You might think, oh my gosh, this is bad. But probably the accuracy of this is there's probably a pretty wide band. The problem with this thing, though, is that insurance companies, if you want to get life insurance, probably 95, 99% of really good life insurance policies are going to make you do this. They're going to send you to their doctor or some doctor that they pay, and that doctor is going to take your blood sample and they're going to analyze it. And based on your blood, they're going to see what risk you are in terms of life insurance and charge you more or charge you less based on your blood. I think that practice is nonsense. I think it leads to a lot of discrimination, but they get away with it because of the numbers. And it's also kind of nonsense because the reality of those predictions is that there's probably a pretty broad band of error. And I think what they do is they ignore that band of error. They pretend that they have a precise prediction based on all these numbers, and they charge you more or less based on those numbers. So I think that's, to me, that's unethical. It ignores the error that's in the predictions. So this leads to this concept of what's called sampling error. So if you remember that we talked about with the poll here is it has a margin of error because we know that the people in their sample doesn't necessarily represent the people who will vote. They may have missed certain types of people. They may have asked some people, are you going to vote? And they say they will, and of course they won't. And they'll ask people, well, will you vote or do you intend to vote? And you say no, but you end up voting anyway. So we know that the sample is not going to be 100% identical to the population. So given that, we know that there's going to be a sampling error. The sampling error is basically the difference between your sample's characteristics and your population in terms of things that you're measuring. So if the variable that you're measuring is who are you going to vote for, we know that there's going to be some error in that. So the statistic that you get from your sample is going to be a little bit off with the true value in the population. So just remember that, and we'll talk about more about this. So again, just one thing to remember about this long lecture is that we are going to review these terms throughout the semester. So this is just a starting point. But I think the concept is relatively easy here, is that your sample will never be 100% identical to your population, and that the numbers that you get from your sample are going to be a little bit off. They're going to be different from the real value in your population. So the difference between your statistic from your sample and the parameter from your population, that difference is called sampling error. So again, on whatever variable you're looking at, whatever thing you're measuring, the number that you get from your sample is almost always going to be different from the actual value of that variable for your whole population. That difference is called sampling error. The difference between the real value the real population parameter and the statistic from your sample, that difference is called sampling error. So for example, if we look at mean, if we look at the mean level of narcissism for Americans, if I were able to measure every single American adult on narcissism, there would be a real true mean. There'd be a real value for the population, a real parameter for the population. However, I can only measure a sample in terms of their narcissism, so I know that my sample's mean and the narcissism will differ to some extent from the real mean of the population, the parameter. So again, that difference is called sampling error. Okay, let's look at the type of analyses that we do in social sciences. So one thing that we do in social sciences, we do correlations. And typically what we do in correlations is we measure two things and we see if those two things correlate. So let's say that I'm studying narcissism. I want to see if narcissism correlates with aggression. And they do, by the way. And so I take a sample, I measure the variable of narcissism, I measure the variable of aggression. And so for everybody in my sample, I have a score for narcissism, a score for aggression. I can just simply correlate those two scores. So if there's a positive correlation, somebody who's high on narcissism will be more aggressive. Somebody who's low on narcissism will be less aggressive. Somebody who's in the middle, who's average on narcissism, will be average on aggression. That's what correlation is you're looking at the relationship between two variables within the same people. And typically, when we talk about correlation, it's not experimental. So not experimental means I'm not manipulating the variables. So I'm not manipulating whether you're narcissistic or not. I'm not manipulating whether you're aggressive or not. I'm just studying you in the real world. In the real world, how narcissistic are you? In the real world, how aggressive are you? So if I'm not manipulating any of the variables, I'm just simply measuring those variables. That's a correlational study. And this is another example here, which is a little bit less exciting than narcissism and aggression. So let's say that we measure, I don't really agree to this because I sleep later. I don't agree with these numbers. This is obviously a biased set of data for early birds. And so for everybody, every student here, and there's students A through H, we ask them what time they wake up, usually. And then we measure their academic performance, which is a GPA, it looks like. And then we can correlate them. And so we have wake up time here, and we have earlier and later. So earlier and later down here, 7 a.m. to 12 p.m. And then for every person, we also measure their GPA. And we can actually plot this. So each of these dots is a person. So somebody who wakes up at 7 a.m. has a 3.8 GPA. See, 7 a.m., 3.8. Here's somebody who wakes up at 8 a.m. and they have a 3 GPA, it looks like. So 8 a.m., GPA of 3.0. So you just plot these numbers. So each dot is a person. And in correlation, we just see if there's a pattern here. And here it looks like there's a pretty big pattern. It's a negative correlation in the sense that the later you wake up, the lower your GPA, which I think is nonsense. This is a biased set of made-up data. But if we just take those numbers as is, there's a negative correlation between those two variables. Negative correlation means that as one goes up, as wake-up time goes up, as wake-up time gets later, GPA goes down. So that's correlational study. So if you study psychology, for example, people have been talking about this forever since your intro class. And so people will often say that the correlational method, because you're not manipulating any variable, you're just looking at how people are in real life, you can't make cause and effect inferences. And you can't explain the relationship. This is nonsense. I'll talk about this, I think, a little bit later too, but this is just shows a bias against non-experimental methods. So there's a ton of things that you can't manipulate ethically. So I study a lot of those things. So I can't ethically manipulate your romantic relationships. It's just not an ethical thing to do. I have to measure you as you are. And even though I have correlational data, I have a lot of explanatory power. And the cause and effect thing is I don't really worry about that too much, but if we measure things over time, there's ways of talking about cause and effect with correlational data. So just my sort of 2 cents about this is there's so much about this in psychology where people say that correlational data can't do much, but I think that's nonsense. I think it shows a bias towards experimental methodology, which I think is BS. I think experimental and non-experimental methodologies are on equal par. But I'm talking about this because every book talks about it, so I want to talk about it, but I want to also debunk it a little bit too. So there's another form of data structures and ways of doing statistics, and that way is comparing groups. So there's different ways of doing this. We'll talk about that in a second, but comparing groups. So when we talked earlier about males versus females in terms of being smart, quote unquote, which is really GPA in that study. So that would be another approach, is we could say, do men versus women, do they differ on GPA? That's this type of approach where we have groups. And that's a non-experimental way of doing it. So we're not manipulating whether somebody's male or female. We're simply looking at males versus females and whether they differ one group versus another group on GPA. But we can also do experimental methodologies. So experimentally, I can manipulate something to see if that manipulation differs, makes you act differently. So I'm going to use an example that we're going to talk about a lot in this class, but it's like 11:30 at night, so that's the only one that I can bring to my mind at the moment. So let's say that I have a theory, and my theory says that the color red leads to more attraction. So if you wear red clothes, people will think that you're more attractive than if you wear other color clothes. And so I could set up an experiment. I could have one group of people see a person in a red shirt. And then I can have those people rate that person's attractiveness. So how attractive is this person to you? Then I can take another group of people. I can have them rate the same person, but that same person is not dressed in red. In this case, they're dressed in blue. So I would have that group of people, separate group of people in this case. They see the person and I say, how attractive is that person to you? And in the end, what I would do is I would compare the people who saw the person in red versus the people that saw the person in blue and see if the people in red gave higher scores of attraction towards that person versus the people that saw that person in blue. So this is an experimental methodology for comparing those two groups of people. So comparing groups of people on another variable, so comparing men versus women on GPA, or comparing people that see somebody in red versus people that see somebody in blue, do they differ in terms of their attraction towards that person? That's another way of doing statistics. So we have statistics that we compare the same people on two variables and see if there's a relationship between those two variables. And then there's a way of doing statistics where we have different groups of people and we compare those different groups of people to see if they differ on some variable, whether that's GPA or attraction or some other thing. So here's an example of a study. So here we have a variable. And so these numbers are aggression. And I'm assuming this violence and no violence could be something that we could do experimentally. So we could have a group of kids come in. So we have a group of kids come in and we divide the kids in half. So half of the kids would watch a violent video. Maybe it's a violent cartoon or something. And then we would put them in a situation where they could be aggressive. So the scores here are on aggression. Maybe there's different ways you could do this. Maybe you could just have them throw them into a group of adults. We don't want them beating up kids. But maybe there's an adult there that they're playing with, and we could see if that kid acts aggressively towards that adult. Then we could do that same thing with the other half of our sample. The other half of our sample would watch a non-violent video. So maybe it would be cartoons too, but it would be non-violent cartoon. And then we would throw the kid in with an adult to interact with them, and then we could rate how aggressive that kid is towards the adult. And we could compare those two groups of kids. Compare the kids who saw the violent video versus the kids that saw the non-violent video. Did they act differently towards the adult in terms of aggression? Is there a difference in the scores? And probably here, there's probably a difference. Maybe not. There's probably a small difference. I'm guessing. We would have to actually calculate this. There's probably a small difference with the violent video group being slightly more aggressive than the non-violent. But I think it would probably be a small effect, just looking at the numbers. We will actually calculate things like this later in the semester to test whether there's actually a difference between these two groups. This is another study we could look at. So this is another experiment. We could bring in college students and we could see if they learn better reading from printed pages or learn better from reading on computer screens. So half of our sample, half of these students, they would read something on printed paper and then be given a test about that stuff. So the scores here are the test scores related to what was written on the printed page. And then we would have the same exact stuff. It'd be the same exact words, the same exact text, but for half of the participants here, half of the students, we would present it on a computer screen. And then we would give them a test to see how well they remembered that stuff. So if we look at this, we see there's an average score of 26 for printed pages, an average of 22 for computer screens. So I'm guessing if we ran this statistic, probably this experiment comparing a group of people reading things on printed paper versus people that read stuff on computer screen, that the people in our sample did better if they had printed pages versus the computer screen. So we're comparing two groups, and these two groups were experimentally manipulated because we chose who saw the printed versus the computer screen. So those are two different ways of doing studies and two different ways of analyzing data. So we just talked about experiments. So we just had two experiments. We had the stuff with the kids, with half of the kids watching a violent video, half of them watching nonviolent, and then seeing if that made a difference in aggressive behavior. And here we experimentally manipulated whether students saw text in a printed page versus seeing the text on a computer screen, and which of those modalities, so modality, printed page versus computer screen, which of those led to better learning. So both of these are experiments. So in both of these experiments, if we found a difference between those groups, if we did our study right, we have a better cause and effect argument because we want the kids to be the same. So we randomly assign kids to whether they're violent or not violent in terms of the video that they watch. So the kids should not differ coming into the study. The only difference should be the manipulation that we gave them, violent versus not violent. Same thing for this study. So we should have randomly selected people to be in the printed page versus the computer screen. If we randomly selected people to those two groups, there should be no difference between the printed group versus the computer group. They should be of equal intelligence. They should be equal in all other things, as long as we randomly selected them to the two different groups. So given that we randomly selected them to the two different groups, they should be the same in terms of their learning. But if they look different after we manipulated the printed versus computer, then we can say, well, these two groups were probably the same coming in, but the differences that we saw in learning in the test scores was directly linked to whether they saw the printed or saw the computer. So our computer versus printed manipulation led to different learning. So there's a cause and effect. We brought in two groups. They should be equal because we randomly selected them to the two groups. If they differ on the learning, the outcome, we have a good argument about cause and effect because the only thing that differed was whether they saw a printed page or the computer. And this then led to different amounts of learning. So we talked about manipulation already. I've used that word. So manipulation is something that you change. So the men and women, whether they differ on GPA, that's not in the manipulation. I can't change your gender. However, I can change whether you see a violent video or see a non-violent video. Or I can manipulate that you read something on a printed page or you read something on a computer screen. I'm changing those things to see if it affects your behavior. Does your watching a violent video versus non-violent video, does that lead to different aggressive behaviors? Does reading something on a printed page versus computer screen, does that lead to different levels of learning? And the last thing that's on this slide is something that's very important in experiments, and that's control. What does control mean? So if we're doing our experiment, we have to do things the same. That's the environmental variables. I'm going to deal with that first. So if we have kids that are watching violent videos versus non-violent videos, we better make sure everything's the same. They better be sitting in the same type of room. They better be sitting in the same types of chairs. I mentioned that both would be cartoons, so we couldn't have something that was, let's say, live action with real people and a cartoon. That would not be comparable because the only thing that should change is violence versus no violence. And so if one's a cartoon and one's live people, we've already thrown in another variable there. It's cartoons versus live. So we don't know if, in that case, whether it was the cartoon versus live stuff that made kids act differently or whether it was the violence. We don't know. So it better be the same thing. It better be cartoons in both, or it better be live action in both. Also, how we interact with the kids. So what we tell the kids should be the same. It shouldn't differ between the two groups. I mentioned in the study we could have adults interacting with the kids and see if they're aggressive. That adult has to be trained to make sure that they act to the kids the same. And a big part of that is we probably want the person to be blind. We probably don't want that person adult interacting with the kid to know whether the kid saw a violent video or a non-violent video, because if they knew that, they would act differently to the kid, towards the kids, and that could actually change the kid's behavior. So we would have to train the adult to act the same to all the kids and to not know whether the kid just saw a violent video or not, because that would change the way they would act with the kid. So those are environmental controls. Same thing for this. So if you're bringing in students and they're reading the text, you better make sure, for one, that the text is the same. So it should be the exact same paragraph or 2 paragraphs or 3 paragraphs. It should be the exact same thing on printed pages versus computer screen. It should be the same type of font. It should be the same size of font. It should be done in the same room. I would argue it should be done in the same room. The experimenter should be trained. They say the exact same thing. So if you want to say something like, read this bit of text and you're going to be given a test to see how well you remember this text, and do the best you can. I want you to do the best thing you can. Try to remember as much as you can. If you say that to the people in the printed pages, you better say that same exact thing to the computer screen people. So there shouldn't be any differences in how you interact with the people in different groups, because how you interact might influence their behaviors. And the only thing that should change is this thing. It should be either the violent versus not violent, or the computer screen versus printed. Everything else should be the same. So that's control. Also, we have control of participant variables. Participant variables are things that can affect the outcome that the person brings in. So these kids are bringing in their personalities. So maybe some personalities are more aggressive than others. The way that we control for participant variables, which we talked about that before, is we randomly assign kids to watch the violent or not violent. If we randomly assign the kids, the group of kids that are seeing the violent video are roughly the same as the group of kids in terms of the non-violent, if we do it randomly. So their personality characteristics that can make them more aggressive should be equalized between the two groups. And so the personality of the kids should be, as groups, equal. And if they're equal, it should have no impact on the group scores. Because if there's personalities here that are more aggressive, there should be the same amount of personalities here that are more aggressive. And so that should not impact the difference, because that personality characteristic is the same across the two groups. So if we've equalized their personality in terms of the groups, those two groups, if we see a difference in the groups, then it's probably the violent versus not violent. It's not because of some sort of personality characteristic that they bring into the study. And then same thing for this. So we should randomly select people, the college students, to printed pages or to computer screen, because there's all sorts of things that they're bringing in that could affect the scores on the test, right? So some people are better readers than other. Some people might have a higher GPA. Some people might be more motivated. So some people come into the study and say, oh, I'm really going to learn a lot from this study. And some people are doing it just because they're forced to. And it's like, screw this thing. So the thing is, all of those characteristics could influence the scores on the test. So what we do is we randomly assign people to the two groups. All of those things that can make a difference, so the reading skills, the motivation, the GPA, all of those things should be equalized across the two groups. And so if those things are equal across the two groups, then if there's any differences in the scores, it's not because of those things, it's because of the computer versus printed pages. So control is really important, because the only thing that we want differing is the thing we're manipulating, the violent versus non-violent video, computer screen versus printed paper. So if we have control and all the other things are equal, and the only thing that is differing across the groups is the thing that you are changing, then we have a very strong argument about cause and effect. So we've already talked about some of this. So methods of control for participant variables is we randomly assign people to groups. We can also do a matching thing. Matching means that if we think that something's going to affect our scores and we can measure it, let's measure it and make sure the groups are equal. And so in terms of this study, and we might think, oh my gosh, there's some kids who are just more aggressive than other kids. We could actually measure that thing. Maybe we could ask a teacher. So we could, if we get permission from the parents, ask the teacher and say, well, this kid's going to be in our study. Can you give a mean, average rating of how aggressive they are? So we have a teacher's evaluation of how aggressive the kid is coming into the study. If we know that stuff, we've measured that stuff, we could equalize that variable across the two groups. So we have some kids that are, the teacher says, oh my gosh, they're really aggressive. We want to make sure that the same number of really aggressive kids are in our violent group as in our nonviolent group. So we know that thing coming in, and we make sure that the very aggressive kids are equally divided between those two groups. We do the same for all of the levels. So we have kids that are average, they're average level aggressive. Well, let's make sure that half of those average aggressive kids are here, half of them are in the other group. And then the kids that the teacher says are not aggressive at all, make sure that half of them are in this group and half of them are in this group. So if we think that there's an aggressive personality and we can measure it, we just do matching and make sure that on that thing we've measured, aggressive personality, it matches equally between the two groups. Same thing for this study. So let's say that we think, oh my gosh, GPA could be something that could affect this. We could actually ask the participants before they come in. We could ask them a question, what's your GPA? So we have them tell us their GPA before they come into our study. And beforehand, we take people who have high GPA and make sure that half of the high GPA people are in this group, half of them are in this group. Then we have the average GPA. Make sure half of them are in this group, half of them are in this group. We have a lower GPA. Make sure half of the lower GPA group is in this group, half of them are in this group. So GPA has been matched and it's been equalized. So with matching, if we know something could affect the test scores and we can measure it, we can equalize that variable across the groups. And so it's a little bit better than random sampling, because random assignment, I should say. So randomly assigning people to different groups, we sort of assume that, okay, everything's equal. But matching says, well, we know that there's some big thing there, let's measure it, and we'll assure that it's equal between our groups. So with both of these methodologies, we are making sure that something that somebody brings into the study, whether it's an aggressive personality or a GPA that reflects how well they can learn, we make sure that those things are equalized and don't play a part in the differences between the two groups. Because we want those two groups, those differences only coming from the thing that we manipulated, the video, or whether they saw the printed or computer screen. Also, we might have a control condition. So a control condition is when they don't have the experimental treatment. So this often comes up with, let's say, I often talk about this with medical research. So let's say that you have some medicine and you think it's going to treat depression. So we want to have a control group that doesn't get the drug, because we want to make sure that the drug is actually making a difference. And in a medical research like that, we usually want to do a placebo. So I think I have this thing here, it's placebo. Placebo is that there's a group of people who are taking something and they think it's the drug. So if there's any effect of, oh, I'm taking medicine for my depression, I'm going to be better. So if there's any sort of hope and optimism of the drug helping you, the placebo will account for that. So the placebo group gets a drug, they think it's going to help them. So that optimism, they might feel better, but it's not because of the drug. So we want to compare the placebo group that doesn't have the drug but is optimistic that the drug is helping them versus the people who really get the medication. So if the medication group does better in terms of depression versus the placebo group, then really that medication has some sort of impact beyond just making people be hopeful about they're going to get better. So control group is a group that does not receive the treatment. In this study, I would say that the nonviolent condition is a control group. So if you think that violence on television or in media leads to more aggression of kids, the no violence is a control group. In this study, there's no control group. There's printed pages, computer screen. I don't really see a lack of experimental treatment here. Here the treatment is exposure to violent videos. So the no violence is a control group. Here there's not really a control group. And the control group or placebo group is important because we want to compare. So this is a baseline. So kids not watching violence on TV, how do they act in terms of aggression? It's a baseline. Then we have a treatment group where we expose them to violence. So does that exposure to violence lead to more aggression? So we have to compare it to the control group. So again, the control and placebo group is we need a comparison group to see if our manipulation, our treatment, changed people's behavior. So we have a lot of other terms here. So I don't know if I've talked about independent and dependent variable. So here we have it right here. So we do our manipulation. We expose kids to violent videos or not violent videos. Or we expose, have people, students read computer screens or printed paper. So we're manipulating things. So the thing that we're manipulating is called an IV. IV, that's called independent variable. Independent variable, IV. That's the thing that you are manipulating as the experimenter. So the IV for that first study is violent versus not violent videos. So I would probably list the video as the amount of violence in the video. And so IV is the thing you're manipulating. IV in the second study is computer screen versus printed paper. That's the thing that you're manipulating as the experimenter. The IV is what you're manipulating. The DV is the dependent variable. That's the outcome. That's the thing that you're trying to affect. So in the first study, my IV violent versus nonviolent video, I think that's going to have an effect on aggression. So aggression is the outcome. Aggression is the DV, dependent variable. In the second study, my independent variable, again, is computer screen versus printed paper. I think that manipulation is going to affect the dependent variable, the DV, of learning, how good somebody learns. So here we have a cause and effect. IV is the cause. DV is the effect. So violent media affects children's aggression. The modality of reading a text, computer versus printed, affects students' learning. So IV, DV is a cause and effect. And you can see that there's a big thing here in terms of timing. So I do my manipulation first. I expose the kids to violent or not violent videos. And then after that, I measure their aggression. So the IV comes first and the DV comes later. I have you read something on a computer screen or on printed paper, and then I measure how well you learn that stuff. So the IV comes first, the DV comes later. So if we're controlling other variables, we're controlling aggressive personality, we're controlling GPA, and everything else that somebody brings in that can affect the DV, we have a very strong argument for cause and effect because the only thing that's different between the two groups is the IV. Violent versus nonviolent videos. computer versus printed paper. So this is true. So all of this I've been saying is true, that experimental manipulation and control helps you make cause and effect inferences. But one thing to remember is that many really important things can't be manipulated, so it's not feasible. So gender identity, personality, we can't manipulate that. Or ethical, we can't tell parents to hit their kids. So if we want to see if physical punishment leads to different outcomes for kids, we can't experimentally manipulate that. We can't tell some parents to hit their kids, some parents not to hit their kids. That's not ethical. So we do need to remember that experiments are not the only way to understand things. The other thing about an experiment that we're a little bit worried about is, yes, we have the cause and effect. We have the IV manipulation. The DV comes later. There's a argument in cause and effect if we have control of other variables. But the problem with that type of way of looking at the world is that we start believing that that one variable is the thing. Experiments sort of ignore that there's multiple causes to human behavior. Human behavior is complex and dynamic, and there's lots of things influencing people's behavior at any point in time. And so experiments tend to focus so much on one single variable, it tends to ignore all of these other factors. These things you can ignore. We just sort of talked about that quite a bit. So we've been talking a lot now about IVs and DVs. Those are experiments. So IV is the thing you manipulate, DV is the outcome. Predictor variable is something that you cannot manipulate, but you want to see the effect it has on your outcome. So for example, I could ask the question, does the level of extroversion relate to depression? So I have a DV there. The DV is depression. Extroversion is something I'm not manipulating. It's something that somebody just has in their personality. So extroversion in this case is a PV, predictor variable. So a predictor variable is something that you do not manipulate, that you want to see how it affects some sort of outcome. So I can't manipulate your extroversion, whether you're extroverted or introverted. I cannot manipulate that, but I want to see if that affects your level of depression. So depression here is a DV. Extroversion is the predictor variable because you're not manipulating it. If you manipulate it to see the effect on that DV, then it's an IV. Violent versus non-violent videos is something you're manipulating. That's an independent variable, and you're seeing whether it affects aggression, DV. I'll stick with aggression as a DV. Let's go back to narcissism. So narcissism, I'm not manipulating how narcissistic you are, but I could see if your level of narcissism affects your level of aggression. So narcissism, I'm not manipulating it. It's a predictor variable. The DV, the outcome I'm looking at, is aggression. So there's some other examples there that you can look at if you want to. And then another term that we need to sort of talk about is discrete versus continuous variables. So discrete variable is something that has separate values. You can't be in between. So a good example that I usually give in class that people resonate with is if I ask you how many siblings you have. So how many siblings you have is discrete. You have 0 siblings, or 1, or 2, or 3, or 4, etc. You can't have 1.5 siblings, or 3.4 siblings, or 2.8 siblings. There's no values in between. There's only values of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's only those values. You can't have 6.2. So that's a discrete variable because you can't have something in between 1 and 2. There's 1, 2. You can't have 1.7. Continuous is you could have any, in reality, you can have any score, any value along the line. So if I study narcissism, for example, I'd say narcissism is a continuous variable. There are many, many, many fine shades of narcissism. Maybe in my way of measuring it, I might have scores of 1, 2, 3, 4, 5, 6, 7, but the actual nature of the variable is that somebody could be anywhere in between. There can be any value of narcissism from low to high. So there's an acknowledgement of something like personality, like narcissism, that you could have all sorts of scores if you measured more finely. But if I'm asking you how many siblings you have, you can only have certain scores, 0, 1, 2, 3. You can't have 1.2. Narcissism, you could have 1.2. So that's the difference between discrete and continuous variables. And this thing about discrete versus continuous is their underlying nature. So the underlying nature of siblings is you have 0, 1, 2, 3, 4. In terms of narcissism, like I just said, I might measure it where I give you scores of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but I know in reality that there are people who are probably 1.2. I'm not measuring it, but in reality, they are 1.2. So we already talked about this. So how many siblings do you have? That better be a discrete variable. How many classes are you taking? Well, probably should ask you during spring. You should be only taking this class in the summer because it's going to be a lot of work. So how many classes are you taking? It's probably also discrete. You're taking 1 class, 2 class, 3 classes, 4 classes in the semester. How outgoing are you? 1 through 10. You might say, well, 10, but maybe you're actually a 9.8. And there definitely are people who are 9.8, so that's probably continuous. How often do you express anger towards others? Never to always. Well, you might say sometimes, but I could give that sometimes a score of 2 maybe, and I'll say you're a 2. But in reality, you might be 2.2, or you might be 2.4. So in terms of things like this, they're continuous variables. You could have a lot of people at different points on the scale from low to high. Okay, we're almost done with the lecture. I know this is a long lecture, and I'm feeling it too. So the last thing we need to cover, which is the most important thing to cover, is levels of measurement. So how do you actually measure your data? So remember with the continuous versus discrete, it's not about how you measure it, but the actual underlying nature of the thing. And personality is that we have a lot of shades from high to low. But with levels of measurement, it's actually about how you actually measure your variables. And why is this important? This is important because it affects the type of statistics that we do. Actually, 70% of the final exam is this very question. Is given the levels of measurement in a study, what statistics that we learned in class is the most appropriate to do given this? And basically what we're going to see is that these numbers, the numbers that we give in the levels of measurement, how we measure our data, that stuff affects the mathematical properties, what sort of math things we can do with it. But let's go ahead and look at some things here. So let's say I ask you this question about what religion are you? And you can just imagine a class and asking a whole class about this. So there's probably a lot of answers, right? We have people that might say Christian. They might even get more specific and say Catholic, for example. Or there might be people that say they're Buddhist, or people that say they're atheist or agnostic. We might have people who are Hindu. We might have people who are Muslim. And so there's all sorts of answers that a sample could give on this. So how can we code this? Well, we could actually code it with numbers. So we could say 1 is Christian, 2 is Catholic, 3 is Muslim, 4 is Buddhist, 5 is Hindu. And so we have these numbers. So what can we do with those data? So let's think about those numbers. Can we add those numbers together? Can we get an average? So can we get an average religion for the class? Add people's numbers together and divide it by the number of people and get an average religion? No, it doesn't make any sense, right? So we can't do math with these numbers. These numbers are just conveying some sort of categories. And so we call this level of measurement nominal. It's about a category, religion. It's a category. We can't say there's more or less. So we can't say that Hinduism is more of a religion than Buddhism in terms of these data. In terms of that variable religion, there's not higher and lower. It's just different types of religion. So we can also do the same thing for biological sex. And I'm bifurcating it as men and women, but we know that there's intersex people, and there's gender is not binary, but I made it a binary here. So we already talked about, do women get higher grades in college compared to men? So we can compare those groups. The women versus men is a nominal level of measurement, because we can't say that women have more gender than men. It's just different gender identities. And so nominal data are also mutually exclusive. So you should only be in one group. So you should only say one religion. If you do a binary thing of men versus women, it's men or women. I don't really believe that's how gender is in reality. That's not the underlying nature. But remember, this is how we measure things, levels of measurement. And so again, it doesn't tell us the degree. And so women are not more sexed, are not more gender than men. It's just different gender identities. So there's no more or less of the variable. It's just different categories of the variable in nominal levels of measurement. And again, in nominal levels of measurement, we cannot do mathematical stuff like adding, subtracting, dividing, etc. So nominal levels of measurement, we can only do certain types of statistics in. Let's look at another data example here. So let me ask you, rank your favorite activity. Watching Netflix alone, going to a big crowded party, hanging out with a few friends. So we have 1, 2, 3. So you've ranked those. 1, 2, 3. What can we do with these data? Can we add these? So for the class, can we add these and say, what's the average preference for Netflix? We can actually do that. We can get an average preference for Netflix. We can get an average preference for big crowded parties. We can get an average preference for, or ranking for, hang out with a few friends. But can we multiply and divide these things to get how much more people want to watch Netflix alone versus being in big crowded parties? We can't do that. So we can do a few simple mathematical operations, but we can't do a lot of mathematical operations because while we have more or less, we know either you as an individual or the class as a group what they prefer more or less, but we don't know the difference. So probably when you do these ranking types of things, you might be frustrated because you say, well, I'm going to give a 1 to Netflix alone and a 2 to a few friends and 3 to parties, but the Netflix alone and hanging out with a few friends, I like both of those things. They're very close together. But the crowded party is very far apart. So these rankings, it's what we call, there's an order there, so we know that there's more or less of your preference, but we don't know that the differences are equal. So the 1, 2, 3, even though there's a 1 number difference between those three things, we don't know if those intervals are equal. In fact, they probably aren't. So the example I gave, the Netflix alone and few friends, could be very close, and the big crowded party could be very far from that. So they're not equal intervals. The distance between Netflix and few friends is very small. The difference between few friends and big crowded party is really huge. So because of that, there's only some mathematical things we can do with it. So it's very limited in the math that we can do. So these are what we call ordinal data. We can say more or less, ordinal, order. You have more of a preference for Netflix versus few friends, and more of a preference of few friends versus big crowded party. So there's more or less of the variable, but there's not equal intervals. So just because Netflix has a 1 and few friends has a 2 and the 3 is for big crowded parties, there's all a difference of 1. It doesn't mean that those are equal differences. So ordinal data, we can say more or less, but they're not equal differences between those numbers. And so this is ordinal. So think about ordinal data being ranking data. And again, we can only do limited mathematical things with ordinal data. In fact, in our class, we're going to kind of ignore ordinal data and just do one statistic that uses ordinal data. I'll explain why we do that later in the semester. And basically with ordinal data, we usually are doing things called non-parametric statistics. What does that mean? Parametric is when there's a normal distribution. And so if we have a variable that is measured in a certain way and we have a normal distribution, we can do parametric statistics. With these ranked order data, because if we plot this, it doesn't make any sense. If we try to plot these numbers, it won't come out to be a normal distribution because we don't know the differences along the horizontal axis. Those are not equal intervals. So we can't actually plot it into a normal distribution. So because we don't have a normal distribution of these data, we don't have a bell curve because we don't know the differences between the scores, between 1, 2, and 3. We don't know how big those differences are. We do non-parametric statistics. Okay, let's think about another data example. So this type of question might look somewhat familiar to you. So on a 4-point scale from strongly disagree to strongly agree, rate these questions. I'm good at doing most things. How much do you agree to that statement? 1 through 4. I'm intelligent. I'm attractive. Okay, so now we have these scores. And we have these scores, let's say, for a whole class. So can we do an average? Can we get an average how much people think they're attractive in the class? Yes, we can. We can add everybody's score together, divide by the number of people, get an average rating about how much they agree to the statement that they're attractive. Can we multiply and divide these things? Yes, sort of. In the world of what the statistics that we're doing is that we can do all of the mathematical operations that we need for all of the statistics with these types of data. Why is that? Is we call this interval level data. So interval level data, we have more or less. So if you say 4 versus 3 versus 2 versus 1, you're saying that you are more attractive. So just like ordinal data, we have more or less. But in this case, we are going to make an assumption that there's equal differences between these scores. And so the difference between 4 and 3 is the same as the difference between 2 and 1. So if we say that there's equal differences between those scores, that is interval level data. But there's no true zero. So there's no lack of agreement here. There's some agreement, but there might be a strongly disagree, but that's not a zero. That's not a true zero, that you don't have any agreement. The true zero is that you don't have any agreement or disagreement. So interval level, there's no true zero. And in psychology, we have a lot of things that are interval level measurement, like personality. So if I measure your extroversion, we would not say that there's a true zero that you lack altogether extroversion. It's either you're more extroverted or you're more introverted. So interval level measurement, just think about a scale like this, 1, 2, 3, 4, where there's equal differences between the numbers. But there's no true zero. You don't lack the variable that we're measuring. So personality, you don't lack personality. You're either higher on narcissism or lower on narcissism. You don't lack narcissism. So a classic example that you hear a lot in statistics is Fahrenheit. So Fahrenheit, what does zero mean in Fahrenheit? Zero doesn't mean there's no temperature. Zero is just part of the scale in Fahrenheit. It's interval because if we look at the difference between 24 degrees and 12 degrees, the difference is 12 degrees, right? That's the same difference in degrees as 112 to 100. So there's equal intervals in this Fahrenheit scale, but there's not a true zero. Because there's not a true zero, we can't do ratios. So we can't say, for example, 60 degrees Fahrenheit is twice as hot as 30 degrees. It doesn't make any sense, right? When I say that in terms of Fahrenheit, it makes absolutely no sense. So because we don't have a true zero, we can't do ratios. That's the one mathematical thing that we can't do. But in our class, if we have something that's close to an interval level of measurement, then all of the statistics that we do in class, we can actually do with interval level measurement. So once we cross that line from ordinal to interval, then the world of the statistics that we're studying in this course opens up to us. The final level of measurement is ratio. So it has all of the same things as interval level measurement. So we have more or less, let's talk about the Fahrenheit scale. That's really convenient. So it's hotter or colder. We have equal intervals. So the difference between 112 and 100 is 12 degrees. It's the same difference as the difference between 20 degrees and 8 degrees. There's 12 degrees difference there. There's equal intervals. The only difference is in ratio, we have a true zero. And if we have a true zero, ratios have meaning. So let's look at speed. Let's look at miles per hour. So let's say that we can be moving at 0 miles per hour, and don't say, oh, your molecules are moving and things like that. Let's just ignore that type of stuff. And so you could have zero velocity. So there's a true zero. So given that there's a true zero in this scale, if you're running 10 miles per hour, that's twice as fast as if you were running at 5 miles per hour. So the ratios have meaning. 5 miles per hour is half of the speed of 10 miles per hour. Oftentimes people pretend that this is ideal, but it's really rare in psychology. So you can't say you have no personality. In psychology, you can't say you lack personality. So in psychology, there's very few ratio level measurements. So again, why do we care? We care because the level of measurement determines the mathematical stuff we can do with those numbers. And the mathematical stuff that we can do with those numbers determines what type of statistics that we're going to be able to do with them. So as we go through this semester, as we go through different statistics, we're going to talk about when is it appropriate to use that statistic with this type of level of measurement. Another reason that we might want to care about level of measurement is we want to think about, does it capture the nature of things that we're studying? So because of the bias towards experimental methodologies and related statistics, so many times when I see personality articles, they often divide people into different groups. So for example, you are narcissistic or not narcissistic, or you're introverted or you're not introverted, or you're extroverted or you're introverted. So extrovert versus introverts. Well, that's not really the nature of personality. Personality is not such that you're either narcissistic or not, or you're introverted or you're extroverted. That's not the reality. The reality is that we lie on a long continuum of an interval scale, but you've just changed that interval scale into a nominal one, into boxes. So nominal really is, or it's really ordinal, but the statistics that we do is nominal. So you create groups. You say that there's introverts and there's extroverts, and you compare those two groups, and you basically treat them as nominal. And so you've taken all of the differences and the nuance of human beings, and you made it into boxes. And to me, putting people in boxes is nasty. You put people in a box and you say you're this thing, and you say they're, because of that, everybody in that box is the same, and because of that, because you're in this box, you're different from the other box. I think that's a bad way of doing psychological measurement. Things are not that way. People are not in boxes. People in a category are not all the same, and people in that one category are not different than people in another category. So I think we really need to think about this in terms of data. When we think about statistics, I want us to think about the data that we have should capture the nature of reality. And if we're measuring things and putting people in boxes, that's actually making things very artificial. And it could lead to many things. It could lead to stereotypes. It could to reinforcing the idea that people are different because of categories. That's not really the nature of people. And so data and how we measure it can actually reinforce stereotypes, reinforce people's prejudices and ideas that people differ, when in reality, people do differ on things, but not on those categories. People are very diverse in those categorical groups, and you're now making them all the same in the box and making them different from the people in the other boxes. So we might want to think about doing more interval level measurement, not putting people in boxes, but putting people on an array of things to capture the reality, the complexity of people. So this is an issue we should think about throughout the course. So this is a summary of the levels of measurement. And basically we go from less things we can do to more things we can do. So nominal, there's very few things we can do mathematically. It limits what we could do statistically. Ordinal, we can do a little bit more, but still it limits us. Interval, ratio, then the world opens up to us. There's so many different statistics we can use with interval and ordinal, or I'm sorry, interval and ratio. So we're basically going from less flexible, less things we can do to more things we can do. And the big change is from nominal versus interval. We don't talk about much about ordinal in this class. So we're going to be using a lot of notation and formulas. So look at Appendix A to sort of review the symbols. So we're going to talk about those symbols. I'll review the symbols, but it's good if you review it yourself also. And I think that this is it for this lecture. That was a really long lecture. And then you're going to have a homework. And in that homework, you're going to be looking at, sorry about this, you're going to be looking at, I hope I have it here somewhere. I don't have it here. Sorry about this. I'm going to pause this. So in your homework, you're going to actually be asked to look at this survey. Do not take this questionnaire. So the homework very clearly says that you're supposed to say what the level of measurements are for the different questions. But every semester, it seems I get one or two people emailing me and saying they're very upset that I'm asking these questions of them. I am not asking you these questions. Do not answer these questions. That would be totally irrelevant. I don't need to know this stuff about you. This is homework in the sense of levels of measurement. So each question you want to ask whether it's measured at the nominal, ordinal, interval, or ratio level of measurement. And so I'm going to have this survey on Canvas. Again, do not take the survey. Just for every question, say what the level of measurement is. And then there's going to be a homework paper that you can basically make an X. You can do it with your computer very easily. For every question, you'll make an X about whether it's nominal, ordinal, interval, or ratio. If you are unsure and want to say that it's two of the things, say why you have two of the X's. So say why you can't decide between two things. So that's your homework assignment that will be on Canvas. So again, do not answer these questions. It's that looking at the question is the level of measurement for each of these questions. Is it nominal, ordinal, interval, or ratio? And so the survey is just to show you how the question is asked. Because level of measurement is not the nature of the variable, it's how you measured the variable. So again, that's your homework, and that's it for this lecture. It's a long lecture, but sometimes we have long lectures in this class. So I'll talk to you when we get to the third topic of central tendency in our next lecture. Have a good day, good night, or good morning, depending on what time it is you're watching this.